So this is, well, these are probably good problems. This is the kind of stuff that's going to really help get you ready for Algebra 2 next year. We'll see some stuff like this, throughout the year in Algebra 2. This is an opportunity to kind of practice something we don't get a lot of practice with normally, doing algebra with inequalities. Okay, so let's take a look at this. So we're supposed to solve for the variable x. In triangle XYZ, they're telling us the three side lengths, right? I think it's probably never a bad idea to just maybe put the triangle on paper and fill in the information. Okay, so if we've got this triangle, and the three side lengths are 3x plus 4, 4x minus 8, and 6x plus 6. Okay. Now let's quickly just review the relationships that we've talked about so far that have to do with triangles. What do we know about the size of an angle and the length of the opposite side? Big angles look at what? Big sides. Right? The bigger the angle, the bigger the size. So big angles look at big sides. Small angles look at small sides. Right? So that's one thing we know. That doesn't end up being that big a deal here, but that's one of the things we talk about in 5.5. What comes into play here is the triangle inequality. What do we know about the lengths of the three sides of a triangle? And this is really important. What about the lengths of the three sides of a triangle? What do they have to do? The angles add up to 180. But the lengths of the three sides, and not that they have to have any particular values.
Any two sides are bigger than the third.
There you go, bingo, that's it. The sum of the lengths of any two sides must be greater than the third side, right? So if that's going to be true, then there ought to be three different ways that we could organize these sides, and three different inequalities that we get out of that. Okay, Savannah, what's one thing we could say here for sure about these? These are the lengths of the three sides, but the sum of any two has to be greater than the third one. What's one thing we could say?
xy plus yz is greater than xc.
Perfect. Okay, so we'll say xy, which is 3x plus 4 plus 4x minus 8, is greater than the other side, which is 6x plus 6, right? So there's one inequality that we can build. 3x plus 4 plus 4x minus 8 is greater than 6x plus 6. Good. So we've taken a geometry concept, the triangle inequality, and we've translated that into an algebra, not equation this time, inequality, right? Now we get to flip the switch and just go into algebra mode for a second. And then we'll come back and look at geometry again in a little bit, but we've got to simplify this. So what do we do to this inequality to solve for x? Good. Okay, so we're going to add up like terms. On the left side, we get how many x's? 7x minus 4 is greater than 6x plus 6. Okay, let's go. I'm going to go about this once the wrong way. And not that it's the wrong way, but it's a little harder, and then you'll see why we don't want to do it this way. What if I just say, okay, well, let's subtract 7x from both sides. So I'll make this red. So this is not the way to do it necessarily. It'll work. Okay, if I do that, then I'm going to get negative 4 is less than negative x plus 6. Then I would probably subtract 6, right? And I'd end up with negative 10 on that side and negative x on this side. But here's the problem. What would I normally do to get rid of that negative 1 if I'm solving for x? Divide by negative 1, right? So if I divide both sides by negative 1, what's that going to do to the signs? It's going to flip it. So this is going to be a 10, and that's going to be an x. But what's tricky about this is, if I multiply or divide by a negative, what do I have to remember to do? Got to remember to flip the sign, and that to me is tricky, right? in my experience as a math teacher, that's one of the most common things that people forget to do, right? So how could we avoid that? How could we make it in this case so we don't even have to worry about it? Yeah, exactly. Why don't we just keep the number of x's positive, right? And then we don't have to worry about it, right? And that's sort of normal for us because we've always done that, right? I've always asked you which direction should we push the x's, right? And we always kind of think of it as let's push them to the left or the right so we can keep the number positive. And we even do that with equations, right? So we're going to go ahead and subtract 6x from both sides. And while we're at it, if we're going to move the x's to the left, in what direction are we going to move the numbers? To the right. So we'll add 4. So the numbers cancel from the right or the left. The variables cancel from the right. I get an x over here, and I get a 10 over there. So there's my first result, right? That's something that has to be true. X has to be greater than 10. Okay? Madison, what's another thing we could say? Now, the first time we said xy plus yz is greater than xz. What's another thing we could say that also has to be true?
XZ, YZ is greater than XY.
Sure. Okay, we could say the sum of these two sides also has to be greater than that side, right? Has to be true. Okay, so let's solve that one. So inequality number 2. 4x minus 8 plus 6x plus 6 has to be greater than 3x plus 4. Right? Okay, now we just get to do some more algebra. So what's our algebra be? What are we going to do next? We did the geometry relationship, turned it into an algebra statement. Now we can flip the switch. We're in algebra mode. So algebraically, what should I do to isolate x? Or what's probably the first thing?
What's the word?
Combine like terms. We'll simplify. Sure. 4x plus 6x, 10x, minus 8 plus 6, minus 2. Everybody agree? Is greater than 3x plus 4. Okay, what are the two steps here next? I want to push the x's which direction?
To the left.
To the left. So I'll subtract 3x. So we're going to push the numbers the other way to the right. And what do we get? Variables cancel, numbers cancel. 7x is greater than 6. Last step? Divide by 7. So we end up with x is greater than 6/7. Okay. There's another answer. Has to be true. Okay. One last thing we can say here. So what's the combination we haven't had? I think it's 3x plus 4 plus 6x plus 6 is greater than 4x minus 8. Is that the one we missed? Okay. So let's start there. Okay, so let's combine like terms. So what am I going to get? 9x, 4 plus 6 is 10, greater than 4x minus 8. Which way do we move the x's? Left. So we subtract 4x. Subtract 10 to move the variables the other way. Notice that if I'm doing this properly, I should always be canceling the numbers on one side and the variables on the other, right? 9x minus 4x, 5x, greater than negative 8 minus 10. What's that? Negative 18? Same thing as adding negative 8 and negative 10. Whoops. And then last step, divide by 5. So I end up with my third result being x is greater than negative 18/5. So now I've got these 3 inequalities, and I've got to set this up so I can make sure that all of them are always true. That's what we have to do, right? So I'm gonna copy these onto the next page and we'll talk about how we do that. Whoops. Okay. First, let's just think our way through this, and I'm going to show you a tricky way to represent this. We have to find, for what are the values of x that would make all of those true at the same time? We have a suggestion. Let's pick a number. Would 1 work? Is 1 greater than 10? No. Is 1 greater than 6/7? Well, yeah, it is, right? Is 1 greater than negative 18/5? Yeah, it is, but it didn't work for that one, did it? Right? So give me a number that would work. 11 would work. That'd be work for all of them. So what do you think the answer is then? Would 10.0000000001 work? It would, wouldn't it? That would be greater than 10, greater than 6/7, and greater than a negative number, right? So what do you think the answer is? Anything greater than 10. Okay, so this inequality sort of absorbs the other ones too, doesn't it? If it's greater than 10, then it has to be greater than 6/7 or greater than negative 18/5. So one way that you could think about that would be the inequality that is the most restrictive is the one that's, that restricts the values the most is the one that we got to keep, right? Because we got to be able to meet all of those criteria. Here's maybe a way to look at it visually. If we graph all of these inequalities, these solutions, so let's say that's 0, so that's going to be -1, -2, -3, -4, etc. Okay, let's graph this one in purple. X is greater than 10. What's that going to look like on this number line? Okay, to the right from 10, do I put a solid dot or an open dot? Open dot, because we're not including 10, right? If it were greater than or equal to, I'd put a solid dot.
Yeah.
Does that make sense? So it's going to look like that. Everybody agree? Okay, how about this one's orange? X is greater than 6/7, so that's just a little bit less than 1, isn't it? Right? So we could put one like maybe right there. Right? And then the last one, we'll make this green. X is greater than negative 18/5. Well, that's negative, what, 5, and 5 goes into 18 3 times with 3 left over, right? So negative 3 3/5. So something like, I don't know, roughly 1, 2. So like right there, kind of. We get the idea, right? Okay, so based on those graphs, what would be the solution that would be shaded for all 3 of them? Yeah, the only part that's overlapping for all of them is going to be this part right there, isn't it? So that's the solution. X is greater than 10. Okay? All right, let's take a quick look at one more of these. Now, you'll see why. There's a reason for this. This isn't just extra practice. There's something that's going on here. We'll go through this one quickly. But there's something that you gotta be able to deal with here. I promise you, this would cause problems on the assignment if you didn't look at this. So we'll go through it quickly. So the first plus the second is greater than the third, right? 6x minus 7 plus 4x minus 5 is greater than 2x minus 6. There's one, right? First plus the third is greater than the second, let's say. Second plus third is greater than first. Okay, so if we solve the first one, combine like terms, we get 10x's on the left minus 12 is greater than 2x minus 6. Keep going. So we'd subtract 2x from both sides to push the variables left, right? Everybody agree with that? Push the numbers the other way, so add 12. Now watch this closely. So we get 8x is greater than 6. So x is greater than 6 over 8. Which we could simplify to say x is greater than 3/4, right? Okay, there's one thing that has to be true. How about here? 6x plus 2x is 8x minus 13 is greater than 4x minus 5. So we subtract 4x from both sides, add 13. We get 4x is greater than 8, so x is greater than 2. Okay, how about over here? Add these up. We get 6x minus 11 is greater than 6x minus 7. Subtract the 6x's, and what happens? Yeah, then I get the result negative 11 is greater than negative 7. Is that ever true?
No.
What does that mean?
It's false.
False. Okay, what if this one hypothetically, so the answer is, yeah, we would write false. You have to write it lowercase, but false is the answer. There's no solution to that system. There's no place, there's no value of x that's going to make those things all true. What if this third result had been slightly different? What if it had been instead, what if we'd gotten the result, let's say, x is less than 1. Is there any place where all three of these would overlap? Look at this one. This one says x has to be greater than 2, and this one says x has to be less than 1. Is that possible to be both at the same time? So if we were to graph each of those inequalities, we would find that unlike this last example, there would never be a place where all three of them would line up. So the answer would be false, because you couldn't do all three of them. And you have to be able to do all three to make a triangle. Does that make sense? Okay. All right, let's